Hello students. Today in this video we're going to look at section 2.2, which is angle similarity of triangles. Now in the last video we talked about similar polygons being proportional. The side lengths are proportional. Well, sometimes you don't know if the polygons, specifically in this case the triangles, are similar. You have to see if they're similar. And one of the ways we can see if they're similar is the angle similarity of triangles. This says that if, and write this down, two corresponding angles of two triangles are congruent, then the triangles are similar. So I'll say that one more time while I'm not standing in front of it. If two corresponding angles of two triangles are congruent, then the triangles are similar. So we just have to prove that two out of the three angles are congruent, and then we can say that the triangles are similar. So let's look at an example. So if I have a triangle, and this is triangle CAT, and I have another triangle that's smaller, and it's triangle DOG. Can I prove that these two triangles are similar? Well, let's see. Do we have two sets of corresponding angles that are congruent? Well, in this one, angle A is a 90-degree angle, and in the small triangle, angle O is a 90-degree angle. So we can say that angle A is congruent, that's an equal sign with the squiggly over it, to angle O. Okay? Now, we also can tell that angle C in the big triangle has one loop, and angle D in the small triangle has a loop. Well, that loop we learned yesterday means that those two are congruent. So we could also say that angle C is congruent to angle D. And since now I've proven that two corresponding angles in two triangles are congruent, then the two triangles have to be similar. And the way we would write that is we would say triangle CAT is similar to, and that's just a squiggly line. That same squiggly line that goes above congruent, but since they're not completely equal, congruent, they're only similar, angles are the same, we use the squiggly, to triangle DOG. So triangle CAT is similar to triangle DOG. Now, if we had lengths of sides, then we could use the proportion to find out a missing length because we figured out that both of those triangles are similar. With our next example, we have two triangles, and we're not given any loops or anything to tell if angles are similar, but we are given some angle measurements. So we've got to figure out if these two triangles are similar based on the measures of their angles. Okay, so I have triangle DEF, and I know that one angle is 90 degrees because it's a right angle, and I know that one angle is 23 degrees. Well, if I look at triangle QRS, I've got one angle that's 67 degrees and one angle that's 90 degrees. So we know that the 67 and the 23 are not the same, but we're missing an angle in each of these triangles. So we need to figure out what that missing angle is. Well, you know that in a triangle, the sum of all three angles equals 180 degrees. So if I know that one angle is 90 and one angle is 23, that when you add 90 and 23 together, you get 113. So I'm going to do 180 minus 113, and I get 10 minus 3 is 7, 7 minus 1 is 6. So I know that this other angle up here must be 67 degrees. Wait. That angle 67 degrees, and that angle 67 degrees. Are they corresponding? Absolutely. We've got corresponding angles. Two right angles. That's my first set of congruent corresponding angles. 67, 67. That's my second. So we can write it like angle E is congruent. Remember, it's the equal sign with the squiggly to angle R. And angle D is congruent to angle Q. So we've proven that two angles are congruent. So I now know that my triangles are similar, so I could write it out. Triangle DEF is similar to, one squiggly, triangle, we got to match the angles. D is corresponding to Q because they're both 67 degrees. E corresponds to R, so it has to come next. And then S corresponds to F, so it comes next. So we notice that the two angles that are in the same position, D and Q are the same, E and R are the same, F and S are the same. That's important when you write your similarity statement. So now we've proven that these two triangles are congruent. So now if we needed to find a missing side, we could set up a proportion. For our last example, we have this crazy picture that includes a triangle embedded inside another triangle. So I have a large triangle, PAT, and I have a small triangle, YRT, and YRT is inside PAT. It's like a big old party. And we need to figure out if they are similar. Well, let's look at it. So there's the first triangle, it's a small triangle. And then there's the large triangle, if I covered up that middle line. So we got two. They both share this angle right here, angle T. Both of them have an angle T. And angle T is the same in YTR as it is in PAT. So there's one angle that is congruent. So I could write angle T is congruent to angle T. You think, well, duh, they're the same. You're right, but we still have to write it down and show that it is congruent. Now here's another rule that you may or may not know. Because this line right here, the RY line, is parallel to the PA line, that means that these two angles are congruent. Always. Because when these two parallel lines happen, the angles are congruent. So I could say that angle P is congruent to angle Y. So now I've proven that two angles are similar, are the same, congruent, sorry, two angles are congruent. So that means the two triangles must be similar. So I would write that as triangle PAT is similar to triangle. Which angle matches angle P in the small triangle? Yes, angle Y. Which angle matches angle A? Angle R. And which angle matches angle T? Angle T. So angle PAT is similar to angle YRT. Now if I had some missing sides, then I could figure out exactly what the missing sides were based on the fact that they're proportional, because we know that the two triangles are similar. And now here are your two practice problems for today's video. The first one says, are these triangles similar? Prove it. I have triangle TWO and triangle PAC. Triangle TWO has a right angle and a 34-degree angle. Triangle PAC has a right angle and a 64-degree angle. So you have to figure out by finding the different angle measures if they are similar. Number two, same thing. Triangle BUS has two angles given. Triangle CAR has two angles given. You have to figure out if they're similar. It says prove it. That means figure out based on angle measures and give me a yes or no with your proof. Once you've finished these problems, take a picture of them and submit it through Edmodo.